The offshore wind industry is now focusing on the deployment of offshore wind turbines in deeper seas, primarily using variant options, technology solutions to foundations such as tension leg platforms or spar buoy supports, foundation supports. At the moment, wind turbine technology is growing in terms of turbine size, with megawatt-class wind turbines being projected for offshore deployment. This project is aiming at providing an interface for the integration of energy storage in offshore wind platforms.
The problem is that renewable energy technologies such as wind and solar power are intermittent, so we cannot predict, or it's very difficult to predict a reliable generation schedule over a substantially long period of time, say between 1, 2 or 3 hours. So storage technology today is gaining a lot of importance. We are working on a new concept for integrating energy storage offshore, so we can integrate this in floating offshore wind turbines under deep sea conditions. And the idea of this is to use the floating platform of a floating wind turbine or any other renewable energy generation technology to integrate compressed energy technology.
Over the past few days, we've been busy deploying the very first FLASC prototype. This represents the first practical application of our technology and is a very important step in our development process. The prototype will allow us to better understand the thermodynamics of the hydropneumatic storage system. It will help us understand the efficiency and any practical challenges that we may encounter when going towards a physical working system. The process of deploying the prototype started with Day 1, where we deployed the gravity anchor, which would serve to keep the system in place. This gravity anchor also houses one of the 2 compressed air storage vessels. This vessel in particular houses a mixture of seawater and air, where there is a liquid piston process. So seawater is pumped into the chamber, causing the fixed volume of air to compress. This was lowered into the seabed using a mobile crane, guided by divers in the water. Once this was in position, we secured the pipes and sensors ready for the next stage of the deployment. The next stage of the deployment consisted of putting in place the upper floating structure. This structure houses the larger compressed air vessel, which is connected to the one at the seabed in order to stabilize the pressure fluctuations as the system charges and discharges. It also serves to provide stabilizing upthrust for the tension leg platform, which also houses the pump work, the hydraulic equipment, and also the energy input, which in our case is solar panels. We chose solar panels because at this scale, a small-scale wind turbine would not really make sense. The deployment process for the upper structure started very early in the morning at the Malta Freeport, specifically at the MetServe quayside facilities. MetServe, who is an industrial partner on this project, and they were responsible for the construction and the manufacturing of the prototype itself. We started from there, transporting it by sea using a standard offshore vessel, which was able to come into the Dock 1 area in the Maltese Grand Harbour, where it was then able to come very close to the shore. The prototype would be picked up by a mobile crane, lifted off from the vessel then could depart, and the prototype itself was lowered into the water, once again guided by divers. And now this is the beauty of having a compressed air vessel integrated into the upper structure, because we could fill up the vessel with a controlled volume of water, which would allow it to sink to the required draft, so we could calculate exactly how much ballasting we need and simply fill it with water. Once it is in position, the divers could connect the mooring chains. We then connect a compressor and start pre-charging the system. So we start preparing the system to receive energy, to start storing energy. But in the process of pre-charging the system, we are also purging the ballasting water. As the ballasting water purges, the weight of the structure reduces and it rises slightly out of the water, causing the chains to come to the required tension. This happens in a very slow and very delicate manner without causing extraneous forces or sudden jerks on the structure. Once the structure is secured and tensioned, the divers were then able to connect sensors to the bottom assembly and basically the system was ready to start storing energy.
Compressing air at sea within seawater will help us to improve the efficiency, and our concept is based on hydropneumatic energy storage, where we are coupling the advancements in hydroelectric power generation on land together with compressed air storage within a seawater environment to enhance the efficiency of compressed energy storage.